Solve the following non-constant coefficient initial value problem using Laplace transform. Okay, so we have y double prime plus 3ty prime minus 6y equals to, here is the coefficient 3t, which is non-constant. Okay, so we cannot solve this equation using the characteristic equation. In any case, we want to use Laplace transforms as indicated. Let's recall Laplace of t times y prime, t times any function, is given by negative 1 raised to 1 due to t raised to 1, so negative 1. Laplace of y prime, and take the derivative, it's the first derivative because t raised to 1, which is negative derivative of Ly prime. By the table or formula, Laplace of y prime is yes Laplace of y, which we denote by uppercase y, minus y0. Okay, and now we take the derivative. By the way, y0 is 0, this is given 0, but if regardless of the value of y0, because it's a constant, and when we differentiate we get 0. Anyways, that's not there, so now we need to find the derivative of this product, s times ys. So derivative of s1 times ys, and we need to distribute this negative sign, s times y prime, and this negative. Okay, now we found the Laplace of ty prime, that's in the middle term here. Anyways, we consider this differential equation. Now we take Laplace on both sides. Okay, take Laplace on both sides, we get Laplace of y double prime plus 3 constant outside, Laplace of ty prime, this is what we just found over here, minus 6 Laplace of y equals Laplace of 2, which is 2 over s. Okay, from the table or the formula, Laplace of y double prime is given by s squared Laplace of y. Now we denote that by uppercase y, minus s y0 minus y prime 0. Okay, Laplace of y double prime plus 3 times Laplace of ty prime, which is here, so 3 times negative ys minus s y prime s, minus 6 Laplace of y, we denote by uppercase y, equals 2 over s. Okay, now sy, this is y0, okay, this is 0, so whole thing is 0, y prime 0 is also 0, and we need to distribute 3 here. And at the same time, now if we consider ys here, once we distribute 3 ys here and ys, we can factor ys out. Okay, then we get, this is when we distribute 3, negative 3 s y prime s. Okay, just coming this, by the way, so y prime, this is the only term with y prime, so distribute negative 3, so we get this. Now from s square ys, negative 3 ys and minus 6 ys, we can factor ys out. Then what is left now? S square here, distribute 3, so this is negative 3 and negative 6. In fact, this is negative 9, equals 2 over s. Now this is a first order linear differential equation in y. Uppercase y is the Laplace of lowercase y with respect to the independent variable s. Now we divide by negative 3s, then we get y prime s plus, this is in fact s squared minus 9, we are dividing by negative 3s, ys equals divide by negative 3s, so 2 over s times negative 3s on the bottom. Let's simplify this, so we have y prime s plus s square over negative 3s minus 9 over negative 3s, so negative 9 over minus 3s is in fact positive 3 over s. I want to put that in the front, and s is square over negative 3s, negative s cancel, s over 3, ys equals, this is negative 2 over 3s square. Okay, this is linear in uppercase y with respect to s. To solve, we find the integrating factor. So integrating factor mu s is e raised to integral of this 3 over s minus s over 3 ds, which is e raised to integral of 3 over s is 3 times 1 over s, so 3 times 1 over s, integral of 1 over s is natural log of s, s is positive, okay, minus integral of s over 3 is 1/3, integral of s is s square over 2. Okay, let's separate into two fractions, I mean two factors. So e raised to 3 ln s, so that's 3 goes here, so e raised to ln s3 times e raised to this negative 1 over 6 s squared, and e and natural log directions cancel, so we have s cubed times e raised to negative 1/6 s squared. Okay, now we multiply this differential equation, okay, both sides by the integrating factor, then we get the left hand side, it will be automatically derivative of dependent variable, which is ys, times integrating factor, which is s cubed e raised to negative 1/6 s squared. Left hand side is equal to, right hand side we have negative 2 over 3 s squared, we are multiplying this by s cubed times e raised to negative 1/6 s squared. Okay, we simplify this, then next we need to integrate both sides. Okay, when we simplify, s squared, 2 copies cancel, just s left, and that is it. So now we integrate, left hand side is just y times s cubed, we have in the right hand side negative 2/3 constant, integration of s times e raised to negative 1/6 s squared ds. Okay, now we need to find the antiderivative in the right hand side, it's a product, and looks like we can do use substitution, because derivative of negative 1/6 s squared is just negative 1/6 times 2s, negative 1/3 s, and negative 1/3 is there, we can take inside if you want to match in this way. Let's do that. So e raised to negative 1/6 s squared, we're going to assume that u, then du would be, derivative is negative 2s, so 2/6 is same as negative 1/3 s ds, so we need negative 1/3 in the front, and we do have negative, let's keep 2 outside, then negative 1/3 take inside, yes, and ds. So this is eu, the remaining negative 1/3 s ds is du. So this is 2, this is basically now it's integral of eu du, which is eu, that means eu negative 1/6 s squared plus c. Okay, that's, we have ys times s cubed e to the negative 1/6 s squared, and to find y we divide by these two factors, then we get ys equals 2, when we divide by this cancel, so 2 over s cubed plus c over everything s cubed e to the negative 1/6 s squared. So e to the negative exponent, let's take this to the top so that this becomes positive exponent, so that is 2 over s cubed plus c e to the negative 1/6 s square over s cubed. Oh, this negative when we take to the top becomes positive, s cubed. Now this is the Laplace transform of little y, and we are supposed to find y. Now we take the inverse Laplace on both sides, we get y. So take inverse Laplace on both sides, that's the Laplace of little y, so yt equals, so this is 2 over s cube. We know the Laplace of t is just t to the 1 over s square, so t square is 2 over s cubed, so this is just t squared. Now this fraction does not have a inverse Laplace because it's too big. When we take the limit of this fraction, when s goes to infinity, this grows faster because the exponential, so c should be 0, otherwise we don't get inverse Laplace, so this should be 0. So in this case this implies c should be 0, otherwise we cannot take the inverse Laplace when c becomes, for c equals 0, because c is a constant, any constant, and that should be 0 in this case, so the whole thing is 0. So yt equals t squared, and that's the final answer because there's nothing left.